This is a continuation of the first lesson from Chapter 9 for Algebra 2. We're just continuing to work with some polynomial operations, starting off with some more multiplication, but instead of multiplying, a term by a term, this time I've got what's called a monomial, which is a single term that's being multiplied by a larger polynomial, which essentially means I'm going to be doing the distributive property. I'm going to be taking this and multiplying it by this, and then I'm going to multiply it by this, and then I'm going to multiply it by this. And we're going to remember all of our rules for multiplication as we do that. So remember, the numbers are just following normal number rules. So I'm doing 1/3 times 12, which works out to be 4. But then for the powers, we want to make sure that we're using the power rules, which if I multiply two powers together, I add the exponents. So x squared times x is going to leave me with an x cubed. Y times y cubed is going to leave me with a y to the 4th. Okay, next one, minus 1/3 times 21 is 7. X squared times x to the 4th makes x to the 6th. Y times y to the 3rd makes y to the 4th. Plus 1/3 times 30 is 10. I don't have any x's over here, so I just keep the x squared that was in that original term. And then y times y to the 4th is going to leave me with y to the 5th. Now, I should double check and make sure I don't have any like terms. I don't believe that I do here, but let's check our x's and y's and make sure we don't have any that match up. I don't see any, so that's just as far as my answer can go. I'm going to leave it right there. Okay, so I think we're probably doing well up till this point. None of this has been super difficult. And really, this next section is not difficult either. But I see people tend to get mixed up between this and one of the other sections that we've already covered. So I want to emphasize this. Notice that this thing inside the parentheses is more than one term. I've got a term here and I've got a term here. Okay? That means I can't just go in here and square this thing and square this thing. You've done problems like this tons and tons of times, and you've used an entirely different method, and I'm going to show you that in just a minute, and you're going to remember. But I just want you to see the difference between this and something like, I don't know, 2xy to the 5th squared. Because this thing is just one term. I mean, it can have as many letters on there as it wants, and as long as there's no pluses or minuses in there, I'm only looking at a monomial. I'm only looking at a single term, which allows me to just square this and square this and square this, okay? But that's not what we're dealing with here, okay? I've got two separate terms here that I have to deal with. So when I say that I'm squaring this thing, what I really mean is that I'm multiplying this parenthesis by that parenthesis again. And then I'm doing the distributive property, which you probably remember as FOIL, okay? But really I'm just distributing twice, just like we did up above. So I'm going to distribute the 2x, and then I'm going to distribute this of ny. I'm going to end up with 4 terms, but I will probably have some that I can combine as like terms. So let's take a look at this. 2x times 2x. 2 times 2 is 4. X times x is x squared. 2x times negative 7y. So I can multiply those, even though the letters are different. The letters aren't really going to combine. They're going to just kind of sit together in the same term like they have been up above and in all the other sections. But 2 times 7 is 14, negative, because the 7's negative. And then I'm just going to write this as xy. Now for my middle term, I've got negative 7 times 2, which is also negative 14. And I'm doing a y times an x. I could write it as yx, but I'm going to switch it around and write it as xy. And I always just try to put the letters in order, like alphabetical order. There's no rule that says you have to do that. But the reason I try to do that is so that I can recognize like terms. If I had written this as yx instead of xy, I may not have noticed that it's the same as this one. So I'm going to be able to combine those in just a minute. And then negative 7y times negative 7y, well, negative 7 times negative 7 is positive 49. And then I'm going to have a y squared. As far as like terms go, I'm going to be able to combine these middle pieces. So my final answer would be 4x squared minus 28xy plus 49x squared. Nope, sorry, not x squared. That last one's a y squared. If it were an x squared, I could combine it, but it's not. It's a y. So that's just as far as my answer can go. All right, so this next one is not a squared binomial. It is just two polynomials being multiplied together, but I'm essentially going to use this same method. I'm just going to start distributing like crazy. So I'm going to distribute the 4m first. I'm going to go 4m times 2m squared. 4 times 2 is 8, and m times m squared is m cubed. Then I'm doing 4m times negative 4m to the fourth n. So go real slow here. 4 times negative 4 is negative 16. M times m to the fourth gives m to the fifth. I don't have an n here, so I just keep the n from this one. And then my last one would be the 4m times the 2, which would just leave me with 8m. Okay. We're going to keep going because now we need to go through and distribute the negative 3n. So at the end of this, I'm going to end up with 6 pieces because I'm multiplying 2 pieces by 3 pieces. So that's always a good way to check yourself and make sure that you've covered everything. It's really important to stay organized here. So negative 3n times 2m squared. Well, negative 3 times 2 is negative 6. And then I'm going to put the m first. So I'm going to put m squared n. Negative 3n times negative 4m to the fourth n. So negative 3 times negative 4 is positive 12. I'm going to keep the m to the fourth. And then n times n is going to give me an n squared. And then the last thing would be negative 3n times 2, which gives me negative 6n. So at this point, I want to check through and see if there are any like terms that I can combine. I'm really going back almost like to what we were doing in this first section when we were doing addition and subtraction, looking for anything that's alike. You won't always have something. Sometimes you will and sometimes you won't. In this one, I don't see any where the m's and n's have exactly the same arrangement of powers on them. So there's really nothing I can combine here. This is just as simplified as my answer can get. And I know you don't look at that and think, oh, that looks simple, but that is simplified as you can possibly make it. Okay, so that would just be your final answer. Okay, that's it for this first chunk of problems. My guess is you have some sections out of the polynomial packet to be working on that correspond with these. So you'll have some time to work on that now before you have to pick up with the next lesson. All right, have a great day.